Good evening, ladies and gentlemen. My name is Amna Mohammed, and I am the ComSoc Chapter Chair, Student Chapter Chair. And I would like to welcome you all to our last event in our event series, Communication Technology, State of the Art and Challenges. Today, we will be hosting two speakers, Engineer Tasneem, Yousif, who will speak on Global Navigation Satellite System Revolution, and CEO of INFINITEWARE, Ameen Altajer, who will give a talk on why decentralization matters. I would like to take this opportunity to encourage all attendees to fill out the feedback form in the chat box for us to gain insight on how we can improve. So without further ado, welcome Engineer Tasneem. Engineer Tasneem Yousif is currently working as a Senior System Administrator at the Benefit Company in Bahrain. She also won several local and international awards like the Excellence Scientific Award by the Kuwaiti Science Club and the 9th International Invention Fair, among many other awards. Moreover, she has published and presented 3 scientific research papers under Internet of Things and computing tracks. She is also the founder and ex-chair of IEEE Bahrain Young Professional Affinity Group and is a current IEEE member. Finally, she is currently a volunteer at Salman Culture Center as an IT teacher. Welcome again, Engineer Tasneem.
Thank you, Amna, and thank you all for having me today, for giving a session about Global Navigation Satellite System Revolution. So today we are going to explain what is the GNSS, and we will give an overview about GPS, and also I'm going to talk about some of GNSS applications. And then I'm going to explain one of the basics about GNSS, which is how GNSS can determine position. And then I'm going also to explain some of the drawbacks of the GNSS. And then I'm going to explain part of my thesis, which was FFT excision, and I'm going to explain a little bit about this algorithm. So first of all, what is GNSS? GNSS stands for Global Navigation Satellite System. It's a collective term that for all worldwide navigation systems that provide users with 3 main things, which is the position, and the position it's a 3D dimensional, velocity like the speed, and the time. How they can provide these 3 information by utilizing a passive ranging of radio signals transmitted by surrounding satellites to the GNSS receivers. So as all of us heard about GPS, actually there is a difference between GNSS and GPS. So what is GPS? GPS, it's a part of the GNSS, which is like a type, and it's invented by the US. So there is different type of GNSS systems. It can be global, and the other type is regional or local. There is 4 main global GNSS systems, which is the GPS, and it's by the US. GLONASS, it's European GNSS. Galileo, it's a Russian, and BeiDou is Chinese. The regional GNSS systems, it's called QZSS, it's Japanese, and NAVIC, or they called it as IRNSS, it's from India. And by the way, these 2 regional GNSS, they are only local, so they work locally or regionally, so their satellites focus only on orbits of their countries. So the satellites, for example, if we assume this is the Earth, okay, and this is India, and this is Japanese, you'll find only these 2 satellites are orbits only above their countries. However, the global GNSS systems, they orbits all over around the Earth. So as you can see, this is the BeiDou Chinese one, GLONASS, it's the Russian, Galileo is the European, and GPS is the most popular and used for a lot of users. It's the American one. And for this session, we will focus about the GPS. So what is GPS? GPS stands for Global Positioning System. It consists of 31 satellite constellations that is used to calculate your position. GPS is developed by the US Department of Defense in 1978. There are 24 satellites in the US constellation. It can orbit every 12 hours at 12,550 miles. And also there is like around 4 satellites in each of the 6 orbits plans. It can transmit a uniquely coded radio signal. Also, it works 24 hours in a day or 7 days in a week. So it has a worldwide coverage. Also, GPS can work however the situation or the condition of the weather. GPS has something called atomic clock. Atomic clock, it's a type of clock that uses certain frequencies of the atoms to keep time with extreme accuracy. So it's a very, very accurate clock. And the electronic components of the atomic clocks are regulated by the frequency of the microwave electromagnetic radiation. And this automatic clock, you will find it in all GNSS satellites because it has a very, very accurate timing, which is important for the GNSS. So as I mentioned, GNSS provide a very critical information, which is the positioning and the timing. So a lot of countries and researchers start to develop like standard or agencies in order to augment or boost the GNSS data. One of these agencies called Satellite Based Augmentation System. It provides higher accuracy, integrity, continuity, availability. So what is accuracy? Accuracy is the difference between a receiver's measured and a real position, speed, or time. Integrity means a system capacity to provide a threshold of confidence or an alarm in the event of abnormality in positioning of the data. For continuity, continuity provide the GNSS data can be continuous without any interruption. Availability is the percentage of time of signal fulfill all these three main criteria. So SPAS provide correction of the data like satellite orbit, satellite clock, atmospheric data that are broadcasted from communication satellites. So it also improves the accuracy and the reliability of the GPS information by correcting the GNS measured errors and provide the integrity of the signals. So this satellite-based augmentation system used by the application that has a critical events like aviation. Of course, it's one of the most important applications of the GNSS. So it's highly used by something called International Civil Aviation Organization, and also it's used by road vehicle fleet management. These are some of the types of SPAS, so it depends on the country. As you can see in the map, some of them are already developed and initiated, and they are working at the moment, and some of them is still planning, so they are under planning, and some of them is still under development, so they are going to initiate them in the near future. So what is GNSS applications? GNSS application has been growing continuously over the last decades. It can be used in military, architecture, space, mapping, time synchronization, aircraft, maritime, ground transportation, and many other applications. So for example, in military, GNSS can help for navigation, for target tracking, for search and rescue. For example, the army can determine the position of the enemy, and they can attack the enemy, and also they can interference the GPSs of the GPS receivers of the enemy, and for this interference, of course, the enemy will lost the location of their of the army, and then they can attack it. So they have a huge applications in the military. The second purpose is the civilian, and for the civilian like us as a human, we use GPS as we use GPS in every day. Like for example, to determine the location for my friend, I use Google Map, and Google Map is, of course, is using GPS. And also engineers like civil engineers or petrochemical engineers use GPS for surveying, for mapping. Like this guy, he's trying to do surveying, finding lost vehicles. So it's very useful if you lost your vehicle, and inside it there is adaptive GPS. You can find the location of the vehicle. Also in agriculture. So for example, in agriculture, you can make a precision farming, you can make a surveying mapping, you can make a water management, and also management of animal disease and control. Mining and railway. For example, you will hear nowadays we are hearing a lot of accidents in railway and collisions. So in order to avoid collisions or passage through switches in the wrong position, we should use GNSS or GPS. For aviation, of course, aviation is, as I mentioned, is one of the important GNSS application to reduce the risk of controlled flight into a major aircraft accident. Maritime applications, so you can monitor of fishing fleet. Fishermen only allowed to catch certain amount of a particular species of fishing. Trails of monitoring fleet corrupting GPS data, because some of the fishers, or let's say the drivers, they try to interference the GPSs in order to do some illegal events. So the users in the company or managers in the company, they can detect if any of the employee try to corrupt the GPS data. So this is some of the GPS types. So this is a portable GPS, and this is the GPS inside our phone. This GPS inside the camera. This GPS in the car. This is a GPS shield, which is educational GPS. I used this one during my undergrad project. I used it to connect it with the Arduino. And this GPS used for mapping and surveying. So why do we need a satellite-based positioning? In order to determine the location, to determine a basic position. For navigation, navigation means like getting from one location to another location, and it's used for car navigation or plane navigation. Tracking, like monitoring the movement of people and things, like fleet management, workforce management, if there is a loss of kids, bit tracking, mapping. To all the maps around the world is created by the GNSS. Can you imagine this? Timing, bring a precise timing of the world. So now let's go a little bit at tech or the basic tech for the GPS. So GPS can transmit its own unique code. Okay, and also there is two main frequencies frequencies that the GPS can transmit the signals. The first one called L1, and the frequency of this carrier is 1575.42 megahertz. The second one is called L2, and the frequency is 1272.60 megahertz. There is two main codes that the GPS can transmit the signals. The first one called CA code, and this one used for civilian applications. The second one called B function of Y, which is used for military applications. All GNSS signals use code division multiple access. Only GLONASS, which is the one for Russia, they use frequency division multiple access. The modulation scheme of GNSS signals are the binary phase shift K, and the various version of binary offset carrier. So how does a GNSS receiver determine its position? This is the basic for the GNSS or the GPS. So first of all, we have these multiple number of satellites. So the satellites will try to transmit a radio signal to the user. This is the guy he's trying to determine the location. And the radio signal, so of course he has, let's assume he has a phone. So the GPS receiver will listen to the radio signal that has been transmitted by the satellite. And then the receiver measures the distance. The receiver will measure the distance from the satellite to the person he's using the GPS. The GNSS receiver compares the time of the signal, the time of sending, and the time of receiving. And this time difference can tell the GNSS receiver how far away the satellite. So now I prepare a simple sketch. Just one second. To make it more clear. So let's assume this is one satellite here, okay? And this is the person, he's anywhere in the earth, and he's trying to determine the location. So how this will how he can you see my screen?
Yes, we can see your screen.
Okay. So the satellite will send a radio signal to the GPS receiver, okay, which is inside a phone, and this will be evaluated by something called time signal, which is the time that the satellite sending the signal, which is signal sending time. And of course, the satellite has a fixed position, which is the satellite position. So here for the GPS receiver, he will, once he receives the signal, he will determine the signal receiving time. So let's assume there is no any error. So in order to get the LE-based time, we will subtract the signal receiving time from the signal sending time, and then we will get the time difference. In order to determine the position, we will multiply the velocity by the time difference. Velocity here is the speed of light. Okay, so back to the slide. So as I mentioned, distance are determined by the signal travel time. Signal travels at the speed of light, and the speed of light is standard, as all of us know. It's around 3 multiplied by 108 meters per second. If the time difference, for example, is 0.067 seconds between the sending time and the receiving time. So by using the formula, which is velocity multiplied by time, so you multiply 0.067 by the speed of light, you will end up by getting, this is the distance of the position of the man he was trying to determine the position. Okay, so my explanation was about only one satellite. So one satellite is not enough. Why? I'm going to explain now, but there is a geometric principle, which is mean you can find one location if you know its distance from other. Already knowing location can be anywhere. So one satellite is not enough, of course. Why? Because the satellite can be here, can be can be here, like it can be all over this surface or circular that orbits around the Earth. So as I mentioned, one satellite is not enough. So we will have like another satellite, okay, and by using another satellite, we will get 2 points. So the location can be here or here. Of course, if we neglect the one that is in an open location, we will get the one that near the surface of the Earth. So this is the correct point. By using 3 satellites, we will get again 2 points. And this 3 satellites mean an algorithm called trilations, but also this three satellites are not enough to determine the position. Accurate timing is very important. So GNSS receivers use a crystal clocks, which is inaccurate clock rather than the atomic clock. So satellites are using atomic clocks, which is very accurate. So of course, when you are sending something from very accurate clock and the receiver is using a different kind of clock, there will be an error. So in order to avoid this error, we will use a 4 satellites. So in order to determine any position, we have to use a minimum 4 satellites.
Engineer Tasneem, I'm very sorry to interrupt you, but can you please hurry up? The other speaker
Okay.
has attended
Yes.
the chat room. I'm very sorry.
Yeah, that's fine. Okay, so I'm going to go to the one of the here. For GNSS, there is some drawbacks and some issues, which is the errors and factors affecting the accuracy of the GNSS data. There is 3 main factors, which is the geometry of the satellite, multipath, and the atmospheric. So what is the geometry of the satellite? Geometry of satellites, to simplify it, it's the space between satellites. So once the space of the satellites is bigger, so it means that they have given a good DOB. DOB is a dilation of precision, which determine how the accuracy the data. So from these 2 pictures, of course, the one that has more space, which is this one, will have a better geometry of the satellites. So this has a good position, the one that on the right. Multipath is meaning that the satellite is sending the signal, but there is like a building or a tower, so the signal will be reflected. So again, they will give an error. Atmospheric mean that the layers of the Earth is different, of course. So these different layers will make a change of the time and the speed. Okay, So one of the solutions I was trying to do during my thesis is applying FFT excision. Applying FFT excision will mitigate the interference and the errors of the GNSS. And of course, there is advantage and disadvantage. Advantage, it has a very efficiency removal of the jammer with different characteristics. Also, it providing estimation of the jammer characteristics. Also, it include radio frequency front end basis. The disadvantage, it has a huge complexity of the hardware because FFT has a multiplication and addition. It's very complex when you implement it on a FPGA or in a hardware device. Also the cost. So that's why we usually use FFT when it comes to critical applications. And this is the algorithm that I was implementing during my thesis. So due to running of time, I cannot explain in details, but I can just show you the results. This is the raw data of the GNSS. So the carrier to noise is a very good, which is over 40 decibel, which means the carrier to noise is very good. When there is interference, as you can see, the signal has been completely destroyed and the carrier to noise has been sharply decreased. After applying the FFT excision, you will find the signal has been improved, and again the carrier to noise has been coming to the normal, which is a little bit under 40, but again it's quite good for the GNSS applications. For future roles, some researchers and engineers trying to mitigate a lot of types of interference. Also, they are trying to enhance machine learning and artificial intelligence with a lot of GNSS application data to increase the accuracy and the posting of the GNSS signals. And also they have invented something called the Q-Best, which is a small satellite that can be used for educational purpose, and it has the same efficiency for normal satellites. Thank you so much.
Thank you, Engineer Tasneem, for your extremely beneficial presentation. I would like to remind our attendees to please fill out the feedback form that was found in the chat box. And now I'll hand over the mic to our webmaster, Ameen, to introduce our next speaker, Ameen Altajer.
Hello, my name is Ameen Altajer. I'm the webmaster of the ComSoc. Today we will be hosting Ameen Altajer. Ameen is the CEO of INFINITEWARE, an artificial intelligence company that provides products and services to several clients across the globe. INFINITEWARE has been working with large clients such as Saudi Aramco, STC, Zain, and the government of Bahrain. Ameen is a Google developer expert in machine learning and has spoke at major tech businesses ranging from Google, Amazon Web Services, and a huge conferences spanning Bahrain, Lebanon, Dubai, and the rest of the world. Welcome, Ameen.
Hey guys, how are you doing today? Is everything okay? Thank you so much for having me. It's such a pleasure. Just like paperwork here. Can you guys hear me well?
Yeah.
Yes, we can hear you.
Perfect. Okay, so I'm just going to start by sharing my screen first, and then we can get down to it. Okay. All right. Cool. Okay. If you can see the screen, just give me a confirmation.
I can't see it. I don't know if the others can. I can't.
Okay. What about the rest? You guys can or can't?
It's because Ms. Tasneem is sharing her screen.
Yeah,
Okay.
I still see Tasneem's.
Okay, no worries.
Can you please, Engineer Tasneem, stop sharing your screen?
Okay. If she can stop it, I'll be able to present. If there's an admin in here, maybe you can just stop the presentation or spelling maybe. Okay, I'm just going to start to share again. Let's see. screen again. Is it working?
Yeah, okay. We can
Yes,
see
we
it
can
now.
see it now.
Perfect. Awesome. All right. Thanks. Okay, so just to check first, do I have 30 minutes or I have an hour?
It's up to you. You can either present for 30 minutes or an hour.
Okay, hopefully it's going to be short and it's going to be tasty. Okay, so thanks very much for having me. I want to thank Amna. I want to thank the rest of the team for facilitating all of this. My name is Ameen Altajer, and today I'm going to be taking you on a journey to understand why decentralization is the way to go. Okay, cool. All right, so first things first, I'm not gonna spend a lot of time about myself. It's really hectic to talk about myself. I'm not a big fan of that, but you can basically go to my website, which is ameenaltajer.com, or follow me on Instagram and Twitter at Ameen Altajer. Currently a Google developer expert, one of only 150 in the world in machine learning with Google. And yeah, I've done game development in the past. I've done blockchain, and not really trading, but the tech itself. I've done work in cybersecurity a lot, and I still do that under our business INFINITEWARE. And speaking about INFINITEWARE, we're actually an AI business, and we've worked with a lot of clients spanning government and the private sector. So I have so we've worked with STC, Zain, Ministry of Interior, Shore Council, and a lot of people as well. And I used to work in Saudi Aramco after I worked in the US and California for a while. So I've been here and I've been there. It's quite a journey, and I think I'm enjoying most of it. And so yeah, that's pretty much about myself. You can always follow what INFINITEWARE is currently doing, currently cooking. So this is a bunch of our clients, and we also do have a product that we created in-house that goes by the name of Kavria, which is a machine learning, basically a chatbot that works offline in an organization, which is really pretty cool because most companies are not really keen about keeping their data in the cloud, believe it or not. And so we try to cater to that by having Kavria to serve their purposes within a closed baby circuit. That really works well for banks and other government entities that are really picky about having their data on the cloud. So there you have it, Kavria. It even understands slang Bahraini, so pretty cool. And under INFINITEWARE, we actually live by 3 rules. The first one is we want to get rid of mundane or repetitive work. You take it from me, I've been working in the corporate world for probably 10 years, so I know by heart how hurtful it is to work in a repetitive environment. And second, we promise to have more intellectual bandwidth so you can focus on what really matters most to you. And third, we actually promise real intelligence powered by machine learning. Not all of this fluff that you hear about online, but real intelligence that can really make value at the end of the day. So that's pretty much it. Okay, cool. So for today's session, we're going to be talking about decentralization. And this is really, really, really an interesting topic. I find a lot of people not understanding what it means and how it's really important. So we're going to be charting this territory today. We're going to be talking about centralized systems, which is an eternal dilemma. And then we're going to be taking a really, 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 really quick tour in the space of blockchain and understand what it means to be a blockchain network and why that is going to be beautiful and useful to all of us. And then we're going to be digging deep into this territory that we call freedom versus convenience, which is a very long debate. And then we're going to be talking about the direction ahead and how we can take things forward. Last but not least, if you guys have any interest, we can kickstart a QA session to solve any of your ongoing conversations in your mind. Cool. So I think we have an interesting topic to discuss today. All right, sweet. So the first topic that I want to talk about is this notion of centralized systems. So everything that we do currently in this current stage that we live in revolves around this idea of having centralized institutions. A good example of that is actually the thought of banks. When you want to send a payment, when you want to send a transaction, you're not going to do it alone. You're definitely going to work with an institution such as a bank. And so BenefitPay is a great example. Even though BenefitPay is not a bank per se, but it is a financial institution that actually facilitates all the payments that we have here, domestically speaking in Bahrain. You've got, STC Cash, you've got, these products by BBK and the other institutions as well. But nonetheless, almost everything that we do has to go through a centralized authority, be certain core functionalities within the government, or certain things within the financial space. And so the million-dollar question is, do you really want to give all of that up in order to have control, or you really, can't give that away? And so it's pretty important to understand that, financial institutions, institutions, make up the majority of our, basically facilities in life, facilities if we're talking about civilization or a community. So everything that we do is basically, revolving around the idea of centralized institutions. A good example is, let's talk about data. So Facebook, Twitter, all of these, conglomerates. There's feedback loop here. Okay, cool. So all of these people, organizations or conglomerates, what I'd like to call, when we deal with these products and services, you're essentially giving the bulk of your data to these institutions, thinking, you have wishful thinking that these people are going to treat your data well, but the reality is that they have a different agenda for your data, and for your privacy. And so this is one way where centralization really strikes big time. The other aspect is the medical institutions out there. When you go to a hospital, hospitals basically retain your medical data, your health data, and there's a lot of stuff that happened there. How can you really trust if those medical institutions are going to play fair and well with your data? And this is another subject that we have in mind. Now, the most apparent one by far is financial institutions. And this revolves around the idea of banks. So if you want to send a payment, as I said in the very beginning, you can't do it alone. Eventually, you're going to have to integrate with financial institutions, which is sometimes very convenient, but nonetheless, you give a lot of power to those institutions, especially when it gets hard. So when you have an economy and you don't control how currency is made, there's a huge chance that a financial institution can really devalue your currency, leaving you in the dark, especially when you have savings and you don't have an income stream per se. So, as we said, the most apparent institution by far that is centralized is your daddy, which is basically the bank. So the bank is, as I'd like to call it, the parent that you did not know that you had, So it's like that you get, so you just get involved in an institute, and basically this era that you're in, and you don't have a lot of power when it comes to choosing where you want to spend your financial power. You take for granted that you have to deal with banks, you have to deal with financial institutions, because this is the way it goes. And you don't have much power when it comes to choosing things. And this is a very big problem. And that dictates, that you have convenience as well. So when you want to send money, you don't have to do a lot of due diligence. You get somebody's bank account most of the times, especially if we're talking about business. You send money across and you're good to go, because you would know that the bank and respective corresponding banks have already done a lot of work making sure that due diligence is in hand. That these banks are not doing any sort of scammy work, and you have proper human beings, proper corporations that are operating within the legal space. And so there's a lot of convenience points that you can get when you work with a bank or institution of that sort. On the other hand, everything that you do has to flow through that institution. And sometimes that is not really the best way to go. Cool? So there's been a lot of talks about how banks operate and the mishaps that they have. And it's so sad that up to this day, banks have a lot of power, over our lives as human beings and citizens. And this is why open banking came on board. Now, open banking is really a great example, and it's really a great segue that can take us to our discussion on blockchain. But the reality is, open banking is this really humble endeavor to allow banks to have APIs. And I'm not sure if you know what APIs are, but if you don't know what APIs are, it's basically a technical gateway that allows people to interact with different systems. So when you have a bank and you have an API next to it, it means that this bank now can exchange data with other parties as well. So imagine you are a business and you want to interact with your customers' data in a legal sense. You can do that with open banking, which is really awesome. But open banking is a different subject on its own. And I do give a lot of talks on open banking that you can check out later down the line. But what I'm trying to say here, open banking is a true and a humble, basically endeavor in order to get the banking environment to open up a bit because it's been closed for a very long time. And the people who suffer the most are citizens or the customer base. Now, you got to understand the regulators are now they're now becoming fed up with this whole thing, with the whole infrastructure work that banks are offering, the financial institutions. They're not really looking to innovate in that space. The reason is, if you want to be a financial institution, it's extremely difficult to be in that space. You have to have basically a lot of liquidity. You got to operate within a specific spectrum that the regulator would agree on. For example, you have to have a compliance department. You have to abide by the AML or anti-money laundering specifics, and that's a lot of work on the legal part and the compliance part. So regulators, because they've inherently made this whole banking experience very hard, it actually works as an advantage for banks. They know that this is a closed club, so you can't just enter in really easily. You have to put a lot of money, and you have to be a big conglomerate in order to join in this big club. And so that did not work for a very long time, because now regulators are asking those banks to actually innovate and become more fluid in that space. And some are doing their best, however, the rest are really, really, really bad. And so if you really sum up everything that we talked about, the reality that we're living in currently is made up of centralized institutions that we don't have a lot of hands, a lot of power when it comes to changing, that atmosphere. And adaptation and adoption is really difficult back in the day. But now regulators are stepping in. You've got technology fields that are coming up, and they give they're exerting more pressure on those conglomerates to operate and change their game. Otherwise, they're going to be left in the dark. And again, this is really a great way to segue now into this topic of blockchain and how it really came on board. So a blockchain is a very confusing, let's say, term to your regular Joe. Your regular Joe, we don't really know that much about blockchain, because I wouldn't really blame them. The media is doing a really good deal when it comes to making sure that that term doesn't get what it deserves in terms of the respect that it should get. And so I want to get you your crash course, a very short crash course on what it means to be a blockchain and what it means to be interacting with blockchain, basically, in this world of decentralization. So it all started back in 2008. Back in 2008, the whole financial crisis happened. And I'm not sure if you guys witnessed it, but we witnessed it back then. And that was really crazy, because if you live in Bahrain, I'm sure you interacted with people who got fired out of their jobs in Bahrain. And you would ask yourself, how is that possible? The financial crisis happened thousands of miles away from Bahrain, and somehow it affected the people that are surrounding me. Well, this is the reality of the economy. The economy is so global right now that everything that touches the West Coast, the US touches the East Coast, and by then it touches Europe, it touches the Middle East. And so it's all a connected network. And so 2008, what happened is, there were financial institutions that were really greedy. One of them is Lehman Brothers. If they've done a lot of work in the CDO space, again, this is a technical term, and basically it's a financial instrument. But what I'm trying to say here is that some of those institutions back then in 2008 didn't do their work, their responsibility, basically, in the right fashion. And they allowed other people to get loans, to get facilities, without really doing enough due diligence and making sure that they can pay their debt. Because remember, the economy is one global network. If you mess up that network in one space, it's going to have ramifications and that avalanche effect and everything that comes through. And so when that happened, a lot of people got fired. A lot of people lost their interest, lost their pension and such. That was really crazy time, honestly speaking. So what has happened back at that time, Bitcoin came on board, and it was actually created by this pseudo entity that nobody knows exactly who we're talking about here. But Bitcoin was actually a digital currency. And you might think for yourself, okay, digital currency. Now, what is so special about that? Well, there's been a lot of endeavors when it comes to creating digital currencies, but Bitcoin was extremely special. Let me tell you why. Now, back in 2009, 2008, this pseudo entity that we talked about goes by the name of Satoshi Nakamoto. And it might sound like it is a Japanese person, but nobody knows for sure. So don't put any speculations here. So these people, let's just call them people, created this digital currency that has no middleman whatsoever. Now, remember my talks about centralized institutions. If you want to send money, you have to go through banks and those institutions in the middle. Now, with Bitcoin, you can send money in a peer-to-peer fashion. So imagine I want to send money to Muhammad. I can say, you know what, Ameen is going to send money to Muhammad without going through anybody in the middle that would take a cut out of my own payment. And that rings a lot of bells, right? So if you think about it, in Bahrain and outside Bahrain, a lot of businesses are built with this middleman sort of mentality. So you do something, I'm going to take a cut out of it, right? I'm not a big fan of that. And so this really hurts well if you're talking about, blue collar and white collar workers as well, because, those remittance services are really abusing people when it comes to getting fees. Sometimes they charge you more when you send less. So this is crazy. It's mind blowing. And so with Bitcoin, it's extremely decentralized, and we're going to get to that in a second. But the idea is there are no middleman for now. When you want to send cash, you just go through the network somehow, and you make your way to the ultimate destination, to the beneficiary, without really doing anything in between. And this has a lot of benefits. Now, what is so special about it, that this work is all under, this open source umbrella. And if you don't know what open source is, it means that your code is actually available online for people to scrutinize, for people to audit, for people to edit if they wanted to, if there's actually value in it. And a great website of that is actually GitHub. You probably know by that, that by now, I'm guessing. And last but not least, so with this digital currency coming in on board, the number one problem that we wanted to solve is the idea of double spending. So double spending is this sort of mentality where you say, you know what, I have a digital asset. How can I move the ownership of that digital asset? Now, the internet is built with no ownership in mind. So if I have a file, I have a song, that's a file, an MP3 song or so, and I send it to somebody else, I'm not going to send them the actual file with its ownership details. You're just going to send them a copy. And this is why people get into that thing. Now, with Bitcoin, you're actually sending the amount, and that money itself as a digital data would change the ownership from yourself into the next person. And this is also facilitated using Bitcoin's actual machinery that we call blockchain. And we're going to get to that in a second. But just remember, this is all powered up by cryptography and a lot of encryption magic that happens under the hood. But so this was extremely crazy, because that means you can send money, meaning you can send digital assets, really with a true sense of assets, with the true sense of the word, meaning you don't have to copy stuff. When you send something, it is being removed from your jurisdiction. And what is so crazy is that now you can create an account on your own, by yourself. If you ever create a bank account here, you know that you have to offer a lot of paperwork. You have to provide your physical address, you have to provide your ID and such. And that actually happens because the economy has to be regulated. The government has to know who you are, where you live. And so when you do any crazy thing, they can actually come back to you and make you pay for it. And that there's no issue with that. And you got to submit your physical address. But the million-dollar question is, do you really have to do that every time? I mean, if I give somebody my address, they're going to hold on to my address and they're going to know who I am exactly. And this is crazy, because this means I have no sense of anonymity in the whole process. I can't, basically hide who I am whenever I do any transaction. Sometimes it has its perks, and sometimes it's actually very invasive. Yeah. And so with Bitcoin, you get that sense of anonymity. Maybe not 100%, but there's a great deal of anonymity that you can gain when you use Bitcoin. Other than that, it's not regulated yet. So many countries are still very picky, and they're dodgy about Bitcoin. They're not really sure if they should keep it regulated. But the funny thing is, you can't really regulate Bitcoin if you wanted to. You can really make it very difficult for people to interact with Bitcoin, but the reality is you don't even need an internet connection to really transact in the Bitcoin space. This is what's so crazy about Bitcoin. It works with cryptography and it works with encryption and such, but it gets you that deal. And last but not least, the whole thing is actually slowed down for a purpose. So slowing down Bitcoin is actually a feature. It's not a flaw. And not a lot of people understand that. But yeah, because it's slow, it doesn't work for a lot of fields, a lot of disciplines. Okay, so let's just have a close-up look in how Bitcoin works and why this is really magical in the decentralization space. Okay, if you ever dealt with, BitTorrent or one of those tools that we used back in the 2000s, maybe, you would remember that peer-to-peer used to be a religious thing. So peer-to-peer is this kind of ecosystem where you can just run an application, search for a song, search for a game, and you can download it. And you don't know how you're downloading it. However, you're downloading files and downloading data, most of the time pirated data, sadly, but you can get access to data without going to an actual website or a server. This was crazy back then. But all of that really relies on this architecture that we call peer-to-peer, meaning you can send data in a specific network where everyone acts like a server. You see, in regular terms, when you want to download something, you have to go to a website. So again, we go into this centralized fashion. You have a server, multiple clients are actually getting the data. Now with this peer-to-peer, architecture, every peer in the system can send and receive, which gives you a flat network. So nobody is the boss, basically. You send and you can receive. And so if you take down a node, you've got other nodes that can reproduce the same work and they can get you the data that you need. And this was the gist of peer-to-peer back then. This is strictly what is happening now with Bitcoin. So Bitcoin is relying on peer-to-peer methodology, and it does that really, really well with a lot of cryptography. So if you worked in the space of cryptography before, you've got so many terms like private keys, public keys, PKI, public key infrastructure, a lot of technical terms. We don't want to go down because this is more of a generic session, but just remember that there's a lot of cryptography in digital signatures and such that are powering this whole ecosystem that we call blockchain. But the idea is you have this platform that we call blockchain, which is the technology that powers this application that we call Bitcoin. So Bitcoin is not the same thing as blockchain. On the contrary, they're really different. Blockchain allows you to do decentralized fashion applications, and it happened that one of them is Bitcoin that we use in the financial space. It was the first, and it is the most apparent, the most common one so far. But yeah, remember, a lot of cryptography. And so for it to work, the system somehow relies on a consensus algorithm that we call proof of work, which essentially says, if you have computational power, if you can calculate things faster, you can prove that, you can prove things much better. And that works in Bitcoin because this is actually an ongoing conversation. So you have your miners that are, trading their computational power for cash, or in this case, Bitcoin. And on the other hand, you have other people who want to transact, that want to do transactions. So it's an ongoing loop. So when you send money, you give money, and then the system rewards those miners when they prove that your transaction is really well and legit. And for them to do that, they have to check that you have enough balance. They have to check that you're not doing anything wrong. And so when they do all of this work, they're being compensated if they can really prove that their work is legit. So basically, when you do mining, you're just computing things really fast, and you're proving to other people in the network that you've done the work of the computation, and now you have to be rewarded. So it's actually a race. So it's a race. When you have different parties, adversaries that don't have a lot in common, when they do these things and they get into this race, whoever comes first with this puzzle solution, you'll be able to reap the fruits, and they're going to be getting the cash. And so this is why it's the wild, wild west, basically, in this Bitcoin space, because you have to mine and you don't have to trust anybody else. Now, it is changing. So you can join in a pool, for example, and work with other people, and they're going to be compensated for the amount of work that you put into mining. But this is essentially what proof of work means. It means that you have to put a lot of effort when it comes to doing computation, and you're going to be compensated with this Bitcoin cut that you get. And it's a lot of money. Okay, now proof of work is old. It started with Bitcoin, but now we're moving into different areas as well. One of them is called proof of stake, if you've probably heard about it. But the idea with proof of work is that you have to dedicate a lot of computational power. It might not be the best way to go, especially if we're talking about, the environment. There's a lot of stuff happening in the environment, but again, we're moving towards other places. But the idea is you can decentralize the idea of consensus. You can allow people to agree on a protocol to prove if a payment or a transaction is correct. Cool. Okay. So when we're talking about blockchain, everybody wonders, why do we have the word block? What is so special about a block? Now, the idea is when you build these transactions, just like what I just talked about a bit, when you're trying to validate those transactions, those miners are actually putting all of these transactions in a bucket that we call a block. And because they do that, and they get a small interest, a very, very small interest on each transaction. So when you're a miner, you're getting money when you do mining from the network itself by the Bitcoin protocols, meaning in the code itself, the code compensates you when you do mining and you win in the competition. But at the same time, if you win, these transactions that you have bulked into one bucket, you get a small fee on every one of those transactions. So it's a win-win situation for you. And there's a lot of money in it. But the idea is when you put them in a bucket, you send it to the network. So the whole network in Bitcoin, they have to agree that this is the block, this is a legit block. Every transaction that is within this block fits the criteria, they're all legit. This is what miners are actually doing. They're just stamping the network with different blocks that contain different transactions, and they're giving the network the notion that, hey, just accept that these transactions are legit. This is why in Bitcoin, when you have a severe computational power, a huge computational power, you can really diverge what is correct and what is true about the network. This is what they call the 51%, if you ever heard about it, which means if you can take over the Bitcoin network, you can control more than 51% of the computational power, you can start forming your own truth. And we did not get to that stage yet because everyone is fighting for their own, basically incentivization. So if you fight for your own incentive, you can't trust anybody. And this is why the network is fair. Everyone is fighting for it, thus, keeping it fair for everyone. But again, I'm not gonna delve very deep in here because Bitcoin deserves its own session. And if you want, I actually have a session that I've done, many sessions on my YouTube channel. You can just write ameenaltajer.com, or you can even check out my training sessions that I've done in Kuwait as well. They're all online. Cool. Now that we know a bit of how Bitcoin works, let's talk about freedom versus convenience, which personally, in my humble opinion, is the ultimate discussion. Okay, so we figured out that centralized is easy, but control. Decentralized is getting easier, but free of control. Now, what would you choose? What would you choose? This is the ultimate, million-dollar question. And I have my thoughts on it, but let me just say, we're not just talking about money. Okay, fine. Financial institutions is a bit tricky because you have government involved. And when we're talking about government, we're talking about regulating the economy, you have money laundering, and you can't blame the government for making sure that everyone is playing nicely because there are terrorists in the world, there are people who want to do bad stuff. And so making sure that transactions and economical power is not going to the wrong hands is an important thing. But it's not just money that we're talking about here, we're talking about data as well. So remember that topic that we just talked about with Facebook and these big conglomerates like Amazon and Google, they all have their own agendas when it comes to data. So what is so beautiful about this decentralization notion is that you don't just apply it for money. You can apply it for other schemes where you have stuff that we share. Now, one of the most difficult things for people to grasp is that when you move into this decentralization space, you have to pick up more responsibilities. And one of them is actually the idea of having keys in your hand. So a good example is if you go to a bank account, you have a bank account, and you do something wrong, you lose your card or whatever it is, you can just call the bank and you tell them, you know what, I lost my card, just give me my credentials back. They're gonna give you a card the second they really validate that you are Ameen, and you are who you claim you are, by providing an identity or an address or whatever it is. Now, in the digital space, when we're talking about the blockchain environment, because this is a decentralized environment and an ecosystem, there is nobody that you can refer to for the ultimate truth, meaning you have to hold on to your credentials, meaning you have to hold on to your passwords and keys. This is why a lot of people struggle when they figure out that in Bitcoin or in blockchain, you can't just go ahead and have your keys in your hand. So if you lose them, you're done for the day. Nobody's going to help you out. It's very difficult to retain or let's say restore your credentials. You have to have copies, maybe backups, but nobody out there is going to help you out when you lose them. Now imagine if you have money in your wallet in Bitcoin and you lose them. Not only that you get damaged, the whole Bitcoin environment, the whole ecosystem gets damaged, because these funds that you lost, they're going to be lost forever from this whole Bitcoin ecosystem. Yeah. So this is why having keys in your hands, it's a huge responsibility, but just remember, this gets you the edge. This gets you the ultimate control over your funds. Nobody out there can freeze your funds. Nobody out there can control what you have. If you think about it, as of today, you don't own your cash. Yes, there are in the bank. These funds are in the bank, but at any moment the bank has a problem, you're going to have a problem. Any time there's an institution that has a problem with you, they can freeze your account. And we're making it better as we grow. So now we have physical wallets as well, hardware wallets, which means, it's not like before where you have to steal a file from somebody in order to control their funds. Just like what happened when Bitcoin started, it's just a file that you steal and you have all of their fortune in your hands. Now we have physical subsystems. So you have to put the actual token in the machine as you transact and you remove the token. And this token is going to have your physical keys, which means it is not stored in your computer. And this is what we call a cold wallet, which means it's actually off the system or offline. Unlike hard wallets where you transact, these wallets much faster. So yeah, it's getting better for all of us. A lot of people had, multiple basically points that they're concerned, let's say, on the Bitcoin environment and such, and you can't blame them because proof of work had been, was actually the first endeavor for the blockchain network to prosper and still the strongest. However, there are different ideas, different methodologies that are being experimented with. Good examples of proof of stake. And that really changes the game, changes the tune, because you're no longer going to be holding on to this idea that, hey, mining is really bad for the environment. Where proof of stake, it's not you doing computational power, but you're relying on a different methodology. In that case, basically how much you own of the network in order to have a say. But that is, again, a different conversation when we're talking about consensus algorithms like proof of work, proof of stake. Just remember, there are different methodologies when it comes to mining now. It's not just your regular mining where you have to run your hardware and leave them and your room becomes hot. This is no longer the case. And just remember with open banking. So open banking is a great deal. And it really goes hand in hand with this idea of opening up this financial system and making sure, that you're doing great things and you have freedom. And it's really simple. You just have your data, and now you have an API next to it. It allows third-party providers, what they call TPPs, businesses, individuals to build applications in order to really benefit and utilize the data that we have as citizens and maybe monetize from it. The problem is, though, if you have not guessed it yet, security is a big problem because when you have a centralized system, it's like a honeypot. A hacker can just come in and focus on one point and they can crack it and you're done for the day. However, with blockchain systems, decentralized systems, the hacker doesn't know where to start. If they want to hack it, they have to know where you are. In a decentralized network, that's really hard. And it is made with a way to self-heal. So imagine you have 1 million nodes and you take over 10 nodes, for example. Those, the remaining nodes are gonna feel the anomaly and they're gonna say those 10 nodes are not playing fair. They have different values. They have a different truth, they're presenting to the network. So we might as well just eliminate them from the network. So it's self-healing. It is the best way to do, basically to run systems as of today. But that doesn't mean that blockchain is always green, to be honest. There are a lot of applications that we still can do for good on blockchain. Well, let me show you some of the cool things that I've found and I really love. So a good example is smart contracts. So smart contracts are, it's basically a very simple term and a fancy term, but what it means is that you have a logical unit, you have a program, but that program doesn't live on a regular server, it lives on a network. A good example is Ethereum. So when you deploy an application on an Ethereum, these applications that we call smart contracts, you no longer can control them, can't change them. The code stays there and it serves its purpose. Now, this is a really huge responsibility because that means if you really screw up the content of the contract or the application, is going to backfire, especially when money is involved. I really urge you to hear a story by this assertive solution that goes by the name of DAO, D-A-W, Distributed Autonomous Organization, which was a smart contract living on Ethereum. And just read the story. It shows you how when you build something, sometimes it's difficult when you run it and it has bugs, okay? And it can really have a lot of ramifications when money is involved, of course. But this is really great because you can automate things that have to do with money now without trusting humans. So imagine you want to pay your rent. You no longer have to trust that this guy is going to pay the rent. The machine itself, the contract, has access to his funds, to this guy's funds, and basically it can withdraw the money, you block it, whatever it is. It can remove your digital asset if you don't pay and such. So smart contracts are really a beautiful tool, and it's giving more leverage to machines over humans, because humans, basically lie, and it's in their DNA to just get away with it. But yeah, Ethereum is a great way to have a new economy. Now, centralized institutions can be really left out, because with Ethereum, we can build programs and institutions and procedures and processes now on top of this blockchain. And this Ethereum, again, deserves a session on its own. So I've seen a lot of good ideas, really good ideas. The problem is their execution differs from one place to another. So I wanted to share something. You probably heard about Libra by Facebook, but it did not do really well because, let's face it, Facebook doesn't have a great track record. It has a lot of problems when it comes to data invasion, infringement, and it's just there. It's a bad basically apple. Everyone knows about it. And even though Libra has a great, let's say, great story, however, the execution might not be so great. On the other hand, we heard also about Ripple. Now, Ripple is a different deal. Ripple is also one of those blockchains, I call them, where they allow people to transact, central banks to send cross-border funds, basically. So we can use it instead of using SWIFT, if you ever heard about SWIFT, for international payment. But that did not really do well because Ripple itself as an organization is very shady. There's a lot to it. Some of its people are, trying to avoid being in interviews for whatever they're providing. So, read about Ripple, read about their history, and you're going to really understand that they're not a blockchain at all. But what they are offering in terms of idea is really beautiful. Cool. One last project that I have a lot of respect for is Blockstack, now named Stacks 2.0, which is all about data sovereignty. So data sovereignty is a pretty big deal. Imagine you want to have access to your data, you want to control your data, just like with Facebook. You don't want to hand over your data to these big conglomerates. Now with Blockstack or Stacks 2.0, you can do that, and you can actually encrypt it on a global provider such as Dropbox, AWS, Microsoft Azure, whatever you choose. You can use it as a host, as basically your harness for your data, and it gets encrypted with your public key, private key combination that we talked about. And then whenever you want to use a service, you get to control. You get to actually offer that data in an ephemeral way, in a temporary way, for that service to provide you with, with the application use cases. Then you can just shut down the access on them if you want to, eventually leaving you in control of the whole process. A great project. Look it up. It's in Python. It's not complicated to read. It's open source. So yeah, what I'm trying to say, just choose wisely. Not everything is a silver bullet. Even where you learn, not everything that you hear online is really a good source for information. Some people, those people are, just big fans of being on stage, to talk about it. It's a trend. Sometimes it's a fad. But the reality is you have to choose your sources if you want to be really good when it comes to understanding how these projects work. And if you have an engineering background, maybe a technical background, that really helps well, because you can read the code and understand if people really can deliver all these promises. And just don't forget that the open source is really awesome. They've done a lot of work, especially in the crypto scene. And yeah, I'll just leave you with that. Choose wisely, choose everything wisely, especially in the blockchain network, blockchain space. Not everything that you hear is really what it does. I hope you really enjoyed it. I'm just going to leave you with that sentiment that I always say to people: in the race of business, data can either make or break your business. And this is not really far from the truth, especially if we're talking about blockchain. If you really love the content, check out my YouTube channel at Ameen Altajer. Just look me up. I put a video every week, and I talk about really cool subjects like dark web, reverse engineering, open banking, great details on blockchain and Bitcoin. And I really dig deep in some of those, basically elements. But yeah, and yeah, here's my YouTube channel. Just make sure you go there and subscribe if you like that. And I hope you really enjoyed it. I'm going to open up for questions. And if you need anything, you can always reach out to me. So thank you for being here. And you guys can just ask whenever you want.
Thank you, Ameen, very much. Thank you for the beneficial presentation.
My pleasure.
If anyone has a question, please feel free to ask.
AK Belushi, I think. He's raising his hand.
Go ahead, please.
Hello, sir.
Hi, how are you?
Sir, I have a question.
Go for it.
Do you advise buying or investing in mining machine?
I'm not a financial advisor, honestly. Really tread carefully in that space. It's a volatile space. You might be making money in one day, you might be losing all of it in one day. So tread carefully, but I can just say that I'm not a financial advisor. So I can't say yes or no. Anybody else?
Thank you.
My pleasure. You guys go ahead.
If I'm like searching for an internship because like I want to learn more, but in like the field of working with like people who actually work with stocks and like open banking and stuff, where do you advise me to like go first with like the training thing?
Okay, did you graduate yet or you're still in university?
No, I'm still in university.
Okay, so the first thing that I'm going to advise on is make sure you have a portfolio. So I'm not sure if you're coming with a CE background or computer science or BIS or whatever it is, but having a portfolio. Okay.
I do have a background because I'm studying in electronics engineering, so they kind of give us a background on like the first year.
Sweet.
So I kind of know a bit about programming and stuff, but they don't teach us the full thing. Like they focus more on the hardware.
Yeah, gotcha. So, okay, so this is maybe out of the direction of the session. Just remember that you're not going to learn everything in university. Institutions are not, in a place to give you everything. They can get you the principles and the concepts and maybe the mindset, but you are on your own when it comes to really bridging that gap with basically, the private, let's say the industry. Now, what I advise on is make sure you get a portfolio, get your hands dirty, and then apply to initiatives and companies that you feel are aligned with your direction in life. So if you want to join a company that has to do with, let's say, artificial intelligence, you might as well contact us. We do a lot of work in that space and we have products in that space. If you want to join a company that has to do with blockchain, maybe trading, let's say, or facilitating, like, let's say, an exchange, in that case, you have rain.ph. If you're interested in people who want to do hardware devices, you might as well go for that as well. So my 2 cents is just work on a portfolio, be very specific on what you want to do, because the experiences that you're going to get and eventually they're going to work you, for free most of the time, or maybe for a very low pay, you got to compensate that by being in the right environment. So just pick where you want to go and have a good portfolio.
Okay, yeah, thank you so much. Well, I know that they're not going to teach us everything in college. That's why I'm asking for an internship. But I might actually like contact INFINITEWARE because I'm really into open banking and stocks and all that kind of stuff. So
sure, sweet. Looking forward to having you on board.
I have kind of have a question too. Would you like hire a new graduated electronic engineer in INFINITEWARE?
We do hardware design, believe it or not, for some of the use cases. But this is another conversation, but just throw us your resume. We'll see what we can do. We'll have a conversation with you guys.
Thank you very much.
My pleasure. But was it clear for everything on blockchain? You guys, you feel you benefited, you understood the whole situation, or?
Yeah, it was very beneficial and I really enjoyed it. Thank you very
Thanks.
much.
My pleasure.
Thank you so much, Ameen.
I feel like I pretty much understand more. Like before I used to like I don't know, like I didn't have an idea about it and they don't teach us about it much and we don't like see it on social media. You know, like you see everyone getting rich by stocks and then you're like, where did I go wrong with mine, you know?
I know. Tell me about it. Yeah, this happens, but trading is different. You know, investing also is different. There's a plethora of stuff under it, and it's but I'm more focused on the tech because I feel that there is a genuine effect. You know, when it comes to our lives as human beings, there's going to be more control, more jurisdiction for us as human beings over our data or over our finances, because sometimes you just go with the flow. You don't have time to reflect and see the things that you can do better. And I think with blockchain, this showed us that we can build systems and institutions in a decentralized fashion without giving control to one authority. And you'll see how that authority can be abused, especially when you work. When you work, you're going to see sometimes the power is in the hands of one person. And if that person is not good, I mean, you're going to go down the drain. And so, yeah, to have that power in the right hands distributed. So your funds in the very end. And I'll tell you what, just one nugget before I leave you here. A good example if we're talking about cash. So the financial system doesn't really involve every nation. And you know that by now. Some nations don't have the ability to participate in this financial system. And it's really hard because sometimes people can't eat, people can't drink water, some people can't have access to education. And because you need this conglomerately, setup that people have to do. But with blockchain, for example, when you have an app on your phone and you participate in this global economy, I mean, you're there. You can just interact with somebody that lives in Canada, for example, for a specific good. To me, this is beautiful. This is amazing. This is where really technology makes a whole lot of value for us instead of just limiting us, to, basically serve other people in this world. But my thoughts. Okay.
Thank you very much, Ameen. Thank you for
My
these beneficial informations.
My pleasure. All right, so
so
so in this case, I'm just gonna have to leave you unless you guys have anything. Emma, if you need anything before I go.
I'm just gonna say that please don't forget to fill the feedback forms. And thank you again, Ameen, for these
My pleasure.
like huge informations for us. Thank you very much.
My pleasure. See you guys. See you guys next time. Bye.
See you. Thank you.